From predicting diseases to powering autonomous vehicles, machine learning, or ML, is at the heart of some of the most transformative technologies of our time. In this episode, we'll explore the origins, types, principles, applications, challenges, and future of machine learning, unveiling its pivotal role in reshaping our world. What is machine learning? Machine learning is a branch of artificial intelligence that focuses on creating systems capable of learning from data and improving over time without being explicitly programmed. Simply put, machine learning enables computers to identify patterns, analyze data, and make decisions, all on their own. From voice recognition to medical diagnostics, ML powers countless applications that have become integral to our daily lives. Cut to graphic. Key features of machine learning. Machine learning models improve as they process more data. Once trained, these models operate with minimal human intervention. ML spans diverse domains, from entertainment to healthcare. ML algorithms handle massive datasets with ease, uncovering insights no human could. The machine learning pipeline. To build a successful machine learning model, we follow a systematic pipeline. It all starts with gathering raw data from reliable sources. The data is cleaned and formatted to ensure quality and usability. We identify or create the most relevant variables to improve performance. Here, we choose the best algorithm and optimize it by minimizing error. The model is evaluated on unseen data to measure accuracy. Once trained, the model is integrated into real-world applications. Continuous monitoring ensures the model remains effective over time. History of machine learning. Let's take a journey through the fascinating history of machine learning. Alan Turing proposes the Turing test. Donald Hebb introduces Hebbian learning, laying the foundation for neural networks. Arthur Samuel coins the term machine learning and develops a program that plays checkers. Frank Rosenblatt designs the perceptron, an early neural network model. Overpromises and lack of computational power led to a decline in AI funding and interest. The resurgence of ML is marked by the development of support vector machines, decision trees, and advanced neural networks. Deep learning transforms ML, revolutionizing industries from healthcare to gaming. Types of machine learning. Machine learning can be categorized into four main types, each tailored to specific tasks. 1. Supervised learning. Examples: spam detection, fraud prevention. Algorithms: linear regression, neural networks. Narrator: supervised learning uses labeled data to predict outcomes. 2. Unsupervised learning. Examples: customer segmentation, anomaly detection. Algorithms: k-means clustering, PCA. Narrator: with no labeled data, these models uncover hidden patterns in datasets. 3. Semi-supervised learning. Examples: text classification, speech recognition. Narrator: this hybrid approach combines small labeled datasets with larger unlabeled ones. 4. Reinforcement learning. Examples: robotics, autonomous vehicles. Algorithms: Q-learning, deep Q networks. Narrator: Here, an agent learns by interacting with its environment and receiving rewards or penalties. Applications of machine learning. 1. Healthcare. Diagnostics. AI-powered tools detect diseases in medical images. Drug discovery. ML accelerates the development of new treatments. 2. Finance. Fraud detection. ML identifies anomalies in transactions. Algorithmic trading. Automates investment strategies. 3. Retail and e-commerce. Recommendation systems. Suggests products based on user behavior. 4. Transportation. Autonomous vehicles. ML powers self-driving cars to navigate safely. 5. Entertainment. Content personalization. Platforms like Netflix recommend shows tailored to your preferences. Challenges in machine learning. While machine learning has immense potential, it's not without its challenges. Garbage in, garbage out. Low-quality data leads to inaccurate predictions. Complex models like deep neural networks can act as black boxes, making their decisions difficult to explain. Training large models requires significant computational resources. Bias in data or algorithms can lead to discriminatory outcomes, and automation raises questions about job displacement. The future of machine learning. The future of machine learning is brimming with possibilities. Key trends. Efforts are underway to make models more transparent, enhancing trust and accountability. This approach trains models across devices without sharing raw data, improving privacy. Quantum computing will enable ML to tackle problems at an unprecedented scale. Automated tools are making machine learning accessible to non-experts. Research is focused on reducing the environmental impact of large-scale training. Machine learning is revolutionizing our world, reshaping industries, solving complex challenges, and driving innovation. As we embrace this transformative technology, let's prioritize ethical development and collaboration, ensuring that machine learning benefits humanity as a whole. Machine learning, powering a smarter future.